Hi guys, so here is your lesson for Friday, April 24th, factoring by difference of perfect squares. So again, we're going to continue factoring, but we're going to go into a different type of factoring method based on what the expression might look like. So first of all, what is a perfect square? Okay, a perfect square is the result of a number multiplied by itself. Okay, so everything in the pink that you see in the table here is a perfect square, because if you take two of the same number, you get a number in the pink. So, for example, 4 is a perfect square because 2 times 2 is 4. Another one, 16 is a perfect square because 4 times 4 is 16. 25, 5 times 5 is 16. That's why these are perfect squares. Okay, so if you need to throughout the lesson, you can revert back to this chart for perfect squares, but you should have these numbers kind of memorized for perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. If not, I'll show you a way in GeoGebra to help you identify perfect squares. So, before we go into finding using the difference of perfect squares method, let's go use the opposite approach. Okay, let's just multiply each set of polynomial expressions. Now, we've done this before. Okay, when we multiply, right, we take the first term and we multiply by each term in the second set of parentheses. So x times x gives me x squared. X times negative 5 gives me negative 5x. And now we do the second term. 5 times x is positive 5x. 5 times negative 5 is negative 25. Okay, clean it up. We combine our like terms. Okay, x and x are the same. This should just be review. Negative 5 plus 5 gives me 0, so they actually cancel each other out. So my answer, my resulting answer, is just x squared minus 25. Okay, now let's go to number 2. We'll do the same thing. Take the first term, 2x, multiply it by each term in the second set of parentheses. 2x times 2x gives me 4x squared. 2x times 1 gives me positive 2x. Then I take my negative 1 and I multiply by 2x. So negative 1 times 2x is negative 2x. Negative 1 times positive 1 is negative 1. Combine your like terms. I combine everything with an x. Up, positive 2 and negative 2, they cancel each other out. So my answer is 4x squared minus 1. Okay, and it says, what do you notice about the resulting expressions? Okay, both answers. Take a look at them and what happened during the process from problem numbers 1 and 2. Well, we had both of our middle terms here cancel out, right? So both middle terms canceled out. Okay, and that's because the answers are perfect squares. If we were to factor these expressions, okay, they're the difference of perfect squares. If you look, 4 is a perfect square, 1 is a perfect square, x squared, and 25. We're going to take a look at that right now if that's confusing for you. So, factoring using the difference of the perfect squares, or the DOPS for short. Okay, there's certain criteria that we have to have in order to be able to factor using a difference of perfect squares. Okay, so the first big one is the expression must be a binomial. We've talked about this. Binomials have two terms. Okay, so if we look at the example here, one term, two terms. So criteria number 1 is met. 2, there must be a subtraction sign between the terms, okay, which we have. Good, right here. And both numbers are perfect squares. Okay, really the numbers in this expression here, right? There's nothing in front, so it's 1 and 1. 1 is a perfect square, right? 1 times 1 gives you 1. 1 is a perfect square. So both numbers here are perfect squares because 1 is the same as 1 times 1, and the other 1 is 1 times 1. So that's good. We met that criteria. And the fourth big criteria is you need to have even exponents. So even numbers are such as 2, 4, 6, 8, 10, and so on. Okay, even exponents. If your exponents here are not even, you cannot use difference of perfect squares. In this example, both of my exponents are even, so we're good. Okay, the result, what you're going to get, is your answer is always going to have a positive and a negative. And you're always going to have A plus B, B. And we're going to take a look at some examples that explain that a little bit further. Okay, so how many terms make up a binomial? 2 terms, like we talked about before. And how do we find a square root? Okay, well, a square root, if you want to know if a number is a square root, okay, let's say we want to ask ourselves, is 9 a perfect square? Okay, you're going to go to GeoGebra. And you're going to use the square root button and type the number. If it is a perfect square, your answer will be a whole number. 3 is a whole number, so 9 is a perfect square. Think about it. 3 times 3 is 9. That makes sense. Okay, let's try another one. How about something like 36? Is it a perfect square? Ah, yeah, it is a perfect square because 6 times 6 is 36. How about something like 24? Is that a perfect square? Not a perfect square because we get a decimal. So that's how you figure out if something is a perfect square. You take the square root and you make sure it equals a whole number. So some examples here. Okay, this is not as hard as it looks. This will hopefully clarify some of the things we just talked about. Okay, first of all, before you can even start to do anything, you need to make sure the criteria is met before you can do difference of perfect squares. So, number 1, is it a binomial? Yeah, it has 2 terms. Does it have subtraction in between the 2 terms? Yeah. Are both numbers perfect squares? Okay, let's think. We have x squared and we have 49. Okay, x squared. Well, x times x is a perfect square, right? X times x is x squared. Anything times itself gives you a perfect square. 49. Well, I'm not really sure if 49 is a perfect square, so let's go to GeoGebra. Square root of 49. Oh, 7. It is a perfect square. So I have 7 times 7. Okay, so now that's good. And I have even exponents. Yep, the exponent I have is 2. That's an even number. Perfect. So now I did all the hard work. Now I get 2 sets of parentheses. I put a plus in one, a minus in the other. Doesn't matter if you put minus and then plus, or plus and then minus. It doesn't matter the order, as long as you have one of each. And now I'm going to take what I have here, and I'm going to put it inside the parentheses. So x squared came first, so I put an x, and 49 came second, so I put 7, 7. And that's my answer. Okay? Both the first terms are the same with x, and both the second terms are the same with 7. The only difference is that one has a plus and one has a minus. That's it. Okay? Number 2, 4x squared minus 1. It is a binomial. It has subtraction. Let's see, are the numbers perfect squares? We have 4x squared, and we have 1. Well, 4 is a perfect square because 2 times 2 is 4, And x squared is a perfect square because x times x is x squared. 1 is always a perfect square because 1 times 1 is x squared. Actually, I'm going to make these into equal signs so it's less confusing. So now I know they're perfect squares and I have even exponents, so I take both sets of parentheses. I give one a plus, I give one a minus. And I'm going to take what I have here, 2x squared, and I'm going to put it first. Or 2x, sorry, because 4x squared came first. Negative 1 came second, so I take what I have for 1, and I put it in the parentheses. Okay, and if you were to check this, if you were to go do exactly what we did here, okay, you should get your original answer. So you don't have to do this. I'll do the check one time. So if we take our answer, 2x squared plus 1 times 2x squared, or 2x minus 1, and I multiply, okay, 2x times 2x gives me 4x squared, 2x times negative 1 gives me negative 2x, 1 times 2x gives me positive 2x, 1 times negative 1 gives me negative 1. When you combine your like terms, the middle two numbers cancel out, and I get 4x squared minus 1, which is exactly what we had in the beginning. Okay, but just keep in mind, this is the answer. This is factoring using difference of perfect squares. Okay, 3. Is it a binomial? Yes. It has subtraction. Are they perfect squares? 144 and b squared. Well, I'm not sure if 144 is a perfect square, so I'm going to go to my calculator. 144. Enter. It is. 12. So we know that 12 times 12 gives me 144. And b squared, we know that b times b is b squared. So I have my numbers. We have even exponents, and I put them in parentheses. Plus, minus. I take my first set, 12, 12, and then I take my second set, b, b. Done. Very simple. And the last one, this looks a little bit more complicated, but it's not. Okay, we have binomial, right, 2 terms. We have subtraction. Let's check for the perfect squares. We have 16h squared and 36k squared. Let's see, square root of 16 gives me 4. Good. So 4, and then we also have h squared, so you have to break up the h squared into 2 separate h's. H times 4h. Think about it. 4 times 4 is 16. H times h is h squared. Okay? 36. Let's check for the square root. Oops. Good. 6. So we know that 6 times 6 is going to give me 36. K squared, k times k. So 6k times 6k is the same thing as 36k squared. So now I set up my parentheses, a plus and a minus, and I take my 4 h's and I put them in, and I take my 6k and I put them in. And we're done. That's your answer. It's fully factored. Okay? What do all of these answers have in common? Okay, so if we look at all of our answers here, we have answer, 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 answer. Notice, okay, that they all have a negative or a positive and a negative symbol, okay? Again, if you have negative before the positive, it's okay. It doesn't matter. And, okay, they have the same number in the first and second spots. Okay, so you notice x, x, 7, 7, 2x, 2x, negative 1, or 1, 1. That's how we use difference of perfect squares. Last slide. Okay, examples where you can't factor using difference of perfect squares. Okay, well, we're going to use our criteria for difference of perfect squares again to figure it out. So, first of all, is it a binomial? Does it have two terms? 1, 2? Yeah. Does it have subtraction? Yeah. Does it have even exponents? No. So, no. Because it has... Oops. I'm going to say it... No, because x to the third is not even. Number 2, p squared minus 99. Okay, two terms, good. It has a negative, perfect. Are they both perfect squares? Well, p squared is p times p. That's good. 99, is that a perfect square? I don't know. Let's see. Square root of 99 gives me a decimal. That's not a perfect square, so I can't do this. No, because 99 is not a perfect square. And 3, does it have two terms? Yes. Does it have a subtraction sign? No. So no, because it has a subtraction sign. Okay, so these are examples where you can't use difference of perfect squares. Alright guys, that's it for today's lesson. Please check out the assignment for today, and I hope you're all doing well. Miss you all. Talk to you soon.